All right, good day, students. My name is Godfrey Uche, an online teacher. I teach physics, chemistry, and mathematics. So, any area of concern in this subject mentioned, please don't hesitate to reach out to me. I'm here to solve your problems in sciences. All right. Okay, now I want to introduce a topic called isotopy, and this topic is meant for SS1. Except you are having this, maybe you are in SS3, and while you are in SS1, you are not able to comprehend what this topic is all about. I think this is your opportunity to comprehend this topic. All right, like I said, we'll be looking at isotopy. Isotopy. What is isotopy? So under chemistry, we shall be looking at what we call isotopy. Isotopy. Today is 5/01/2026. All right. Now the question is, I believe you are with your pen and your paper. The question is, what is an isotopy? An isotopy is a phenomenon whereby two or more atoms have the same atomic number but different mass number. Full stop. That is what we call isotopy. A phenomenon, take it again, a phenomenon whereby two or more atoms have the same atomic number but different mass numbers. This is due to difference in number of neutrons. This is due to difference in number of neutrons. Sometimes you'll be given an atom with mass number and atomic number. You may not understand how to calculate the number of neutrons in that atom. Just like, for example, if we have something like potassium, you might be given potassium element as this is 39 and the atomic number is 19. Remember that mass number is always at the top, while the atomic number is always at the bottom. Don't also be confused that we have another name for mass number and another name for atomic number. What's another name for mass number? Another name for mass number is what we call nucleon number, while another name for atomic number is what we call proton number. Why is it called proton number? It's because it is atomic number is the number of protons. That's why it's called proton number. All right. Then why mass number is called nucleon number? It's because mass number is the sum of protons and neutrons in the nucleus of an atom. So they are all inside the nucleus. That's why they are called nucleon number. Now the question is, how do you calculate the number of neutrons? Now, how do I calculate the number of neutrons? Number of neutrons is equal to mass number. Mass number is equal to mass number minus atomic number. Mass number minus atomic number. That's the number of. Now, what is the mass number? That is 39. We have 39 minus. This is mass number 39. Atomic number is 19. So we have 39 minus 19. That will give us 20 neutrons. It's as simple as that. It's as simple as that. So 20 neutrons. That is the number of neutrons in this particular atom or element, right? Is that taken? All right. Now, be that as it may, we are still talking about isotopy. Like I said, that isotopy is a phenomenon whereby two or more atoms have the same atomic number but different mass numbers due to difference in number of neutrons. All right. Now, atoms that exhibit this isotopy, they are called isotopes. Atoms that behave like this, having the same atomic numbers but different mass numbers. The same atomic number but different mass numbers. They are called isotopes. Example of elements that exhibit isotopy is chlorine. We also have oxygen, we have sulfur, and many others. they exhibit what we call isotopy. Now, let me give you for instance, what isotopes are all about. Remember, there were any atoms that exhibit this isotopy, they are called isotopes. Now, look at this. We have chlorine, we have 35 and 17. Then we have another chlorine atom having 37 and 17. You can see they have the same atomic number but different mass numbers. That is what makes them isotopes. That's why now in GC equation they ask, what are isotopes? What are isotopes? Isotopes, now this time, now so that you know the difference between isotopy and isotopes. What are isotopes? Isotopes are atoms of the same element having the same atomic number but different mass numbers. But isotopy is a phenomenon. It's a phenomenon whereby two or more atoms have the same atomic number but different mass numbers. This is due to different number of neutrons. But isotopes are atoms of the same element having the same atomic number but different mass numbers. That is what isotopes are all about. Like this particular example, chlorine, example of an element that is bit isotopy is chlorine. Look at it. Chlorine has two isotopes. We have one of mass number 35, we have one of mass number 37. So that is what makes chlorine to exhibit isotopes. Now listen again, very, very important. They ask a question. Now, in one question they ask, explain briefly why the relative atomic mass of chlorine is 35.5. Explain briefly why the relative atomic mass of chlorine is 35.5. Now, from the explanation I'm going to give you now, you can be able to resolve that. Now, listen. The reason why the relative atomic mass of elements are not whole numbers is because of the existence of isotopes. Take it again. The reason why the relative atomic masses of elements are not whole numbers is because of the existence of isotopes or the presence of isotopes. Now look at how Wyatt turns the question. Explain briefly why the relative atomic mass of chlorine is 35.5. So they are telling you now, why is it that it's not a whole number? That's it. So your answer should be that the reason why they are is 35.5 is because of the presence of isotopes. It's because of the presence of isotopes. So that is why the relative atomic mass of chlorine is 35.5. Alright, now be that as it may, now from the discovery, listen to this. If they ask you the characteristics of isotopes, now number one, isotopes differ partially in their physical properties. Isotopes differ partially in their physical properties, but similar in their chemical properties. Why is it that isotopes differ in their physical properties but similar in their chemical properties? The reason why they are similar in their chemical properties is because they have the same atomic number. Because they have the same atomic number. That is why they are similar, they are the same in their chemical properties. But in terms of physical properties, they differ partially. Why? It's because of difference in mass numbers. That is an indication that the mass numbers only address the physical properties, while the atomic number addresses the chemical properties. I believe that is taken. Alright, now I'm going to do one calculation. I believe the next class we are going to meet again. I'm going to do one calculation. Then in the next class we are going to do more than you expected. I'm going to give you several examples. At the end of the day, you may not have any excuse on how to solve any problem concerning isotope. Any problem you see after teaching you on this topic, any question under isotopes, if you can't solve it, come and hold me responsible. So what you do, you play it over and over until it diffuses into you, and I bet you become outstanding in your class. All right, now let's look at this one example before we call it a day. All right, now look at this. Look at this. Look at this. Now look at this. Now example 1. Okay, before I go into that, there are briefly objective questions they may like to. I don't want to skip anything. These are theory. These are objectives. Now there are some likely questions they will ask you. A special objective question: which of the following isotopes exhibit isotopic mixture? Or which of the following are isotopes? They will ask you this question. Which of the following are isotopes? Which of the following are isotopes? Now look at this. You may have, let's say we have X here, and we have T, we have S. Then this one, we have Y, we have T, we also have X. Or let's say we have R here. Okay? Now another option might be like we have O here, P, X, then here another O, we have S and then X. So let's work with this example, with these two, because if you know what it means, even though it's solved to option D, you will know the right one. Now remember, they say which of the atoms exhibit isotopic mixture? Which of them are isotopic mixture? Which of them behaves like isotopes? Now look at this one. If you look at the definition, atoms of the same element. That's what we call isotopes. Atoms of the same element. Atoms of the same elements having the same atomic numbers but different mass numbers. So if you look at this one, atoms of the same element. Now look at this atom, this element and this element. They are not the same. So that means this one is out of it. It's odd. It's out of it. It's not. They are not isotopes. But look at this. We have element O. The same element, atoms of the same element, having different mass numbers but the same atomic number. So this one becomes the right one. That's how to solve problem on isotope. That's how to solve problem. I teach by inspiration. I know what you want to pass your work, jam. Even though you're an SS1, there's no problem with that. If you see jam question, you just mess it up. Once you see jam question under this, you mess it up. I'm telling you the truth. Just continue to follow me on my page, and I bet you will be the best, honestly. I'm not saying it because I want to say it. Just follow my page on YouTube, Facebook. I am giving you my word that you will be outstanding in your class, because I was once outstanding in my own class. All right, now let's look at one example. Now, example one. Very simple. Example one. Now, we have chlorine. Chlorine consists of two isotopes. Look at it. Of two isotopes. What are these isotopes? 75%. That is the relative abundance. 75% of chlorine, 35 and 17. This is 35 and 17. Then 25% of chlorine, 37 and 17. Find the relative atomic mass. Relative atomic mass of chlorine. Very simple. Now this percentage, they are called relative abundance. That means their occurrence in nature, their quantity in nature. That's what we mean by relative abundance. Now, how do you solve this? Now, we have these isotopes. We also have these isotopes. So you need to know the contribution made by each of the isotopes. Now, we are looking at the first one. we are looking at the solution. Now, contribution. First of all, let's look at the contribution made by the first isotope, which is a contribution made by the chlorine of mass number. Chlorine of mass number. Chlorine of mass number. Chlorine of mass number 35. Let's look at that one. Is equal to the contribution made by it is equal to 75 times 35. Right? So we get the answer after now. Now we have contribution made by the next isotope, which is 37 and 17 is equal to 25, because that's the relative abundance. So relative abundance, that's 25. Contribution made is 25 times 37. So we have times 37. So we look at that. Now let's look at, please use your calculator and check what is 75 times 35. Please use your calculator and check. Alright, now having done that, now we have 35 times 75. If you check your calculator, is 2,625. 2,625. 2,625. While 25 times 37 will give us 925. Alright. Now the question is, what is then the total contribution? We have what we call total contribution. Total contribution. What is the total contribution? Total contribution is equal to 2,625 plus 925. That will give us 3,550. 3,550. Now, what is the next thing? The next thing is that what then is the total relative abundance? Total relative abundance. Total relative abundance. What is total relative abundance? Now, we have the total relative abundance. The abundance of this one is 75. 75. That's 75. Then plus the abundance of this particular isotope is 25. So if you add them, you have 100. Then, therefore, the relative atomic mass of chlorine, chlorine, let's use the symbol, is equal to the total contribution, that is 3,550, all divided by 100, the total relative abundance. So when total contribution, look at the total contribution, the contribution made by these two isotopes, look at their sum. Alright? That is the total contribution. Then total abundance, that is 100. That's what you have. So total contribution divided by total relative abundance. So that will give us 35.5. So that is the relative atomic mass of chlorine. Alright? I believe you have comprehended all of this. In case you have any question, please drop your question on the comment section. I will attend to you. Alright, my next video will be coming up by tomorrow. So we shall be looking at some other questions that relate isotopy. So I'm going to exhaust all the questions, like I promised, that after following me up on this topic, there is no problem under isotopy you cannot solve. Be you in SS1, you can address jam questions that has to do with isotope without any fear. Alright, see you next class. I still remain Godfrey, the online science teacher. Thank you so much for watching.